Earlier we talked about the toString method that exists in the object class. It turns out that there's also an equals method that exists in the object class. So in other words, we automatically have an equals method available to test whether two objects of the same class presumably are equal or not. And the reason it does what it does is because it's been defined in the object class to do what it does. And what it does is it essentially checks to see if the references for the two objects are the same. Because at that level, at the highest root level, equality can only be deduced as the two objects being the same object. And that in turn can only be deduced by them having the same reference. That's probably not what we're generally going to mean or understand by equality. For example, if you have two separate square objects and they're exactly the same size and the same color and everything is exactly the same, then even though they may live in two different areas of memory because they have two different references because they are two separate objects, we could still judge them as being equal. And the equals method that exists in the object class will not accurately reflect that, because as long as those are two separate objects, it doesn't matter that they look the same. They're going to be different because their references are different. So this gives rise to the fact that we may wish to override that equals method to make something that's more compatible with whatever it is we are trying to compare. Let's look a little bit further at this equals implementation that's in the object class. It basically looks like what you see here. So we have a publicly accessible method that returns a boolean. It's called equals, and it accepts an object as of the object class as a parameter. What it does is it returns the boolean result of comparing this, meaning the reference of the calling object, to obj, which is the past object as an argument. So if those two things are the same, what we mean by that is they have the same reference. They're acting as two reference variables, and if they point to the same object, they're judged as being equal because there's only one object there, so of course they're equal. But again, that's probably not going to be terribly useful to us most of the time. As a result, we're quite often going to want to override the default equals method in the object class with something that's more suitable for us. And in doing so, how we determine equality is up to us. We could say that two circles are only equal if they have the same diameter, the same color, and the same filled status, and we could even insist on the same creation date for that matter. We probably wouldn't want to do that, but we could. So it's up to us to determine what we mean by equality. This can give rise to some interesting problems. For example, if we're going to judge two rectangles, or maybe two triangles are a better example, then how do we decide what equality means amongst two triangles? Are we going to sort of talk about side 1, side 2, side 3 and insist on those three sides in that order being the same? Or are we going to recognize that no matter how we rotate a triangle and which side we consider side 1 and side 2 and side 3, we could have the same equivalent triangle even though the sides are somehow in a different order. So in other words, if you had a triangle of side length 1 and length 2 and length 3, and you had another triangle that had the first side of length 3 and the second side of length 1 and the third side of length 2, clearly it wouldn't matter. They're still the same triangle. It's just a matter of rotating it or flipping it and realizing that you can put them on top of each other and they line up, and therefore this is the same triangle. And that on that basis, we might want to judge them both as being equal. So it may be tricky to determine what's equal and what's not equal. And again, we may choose to include the color or exclude the color. There may be some other parameters that we use to determine equality, but in any case, the point is we're probably not going to be interested in comparing the references to decide if two objects are equal or not. So in the code that you see here is an example of how we might want to override the equals method for the circle object. What we do is the first thing we do is make sure we actually have a circle, because we need to recognize that we could be passing just a generic object to this equals method, and it's only appropriate to compare radiuses if these are actually circles. So on the one hand, we know that we may be using a calling object that's a circle, but the parameter that's passed to compare it to is just an object. It might not be a circle necessarily, so we better start by making sure it is a circle. To do that, then, we say if O, that is the object I was passed, is an instance of a circle, then I know it's okay to compare radiuses. So then I will return radius equals, and then I first of all have to cast the passed object to look like a circle, so that you see a cast in front of the O. And then for the reasons we already discussed earlier, you need that extra pair of parentheses around this whole thing before you do the dot radius part. And if those two radii are equal, the one in the calling object and the one in the parameter object, if they're the same radius, then that will be good enough for us to say these are the same circle, these are equal circles, and we'll go ahead and return that value. Now, if the radiuses aren't the same, then of course that value will be false that we return instead. I'm not talking about the bottom where it says return false, but I'm talking about where it says return radius equals, because it might be the case that those two radii are not equal, in which case that Boolean expression is false. You'll notice there is an else part though, and it returns false all the time. And the reason it does that is if you haven't even been passed as an argument a circle, then there's no way it could be equivalent to the circle that we're trying to compare it against, because there's no way a circle can be equal to a square or a triangle or some other figure. So if that initial if is false and O is not an instance of a circle, then immediately we're going to say, well, the other thing can't be an equal circle because it's not even a circle. So we just simply return false right away. Now, just to emphasize what happens when we use the default equals method that exists in the object class, if you take a look at the code on the left hand side of this slide, we've declared two circles, both radius 1, so you would imagine they are equal circles, but that is their actual type. Their declared type is just object. So we have O1 and O2 both declared to be objects, but the actual type is a circle. Because they're declared to be objects, if we use the equals method with them, as you see in the if statement down in the middle of that code, if we say if O1 dot equals O2, then we're going to get that default inherited equals method that comes with the object class. That's shown in the bottom right hand side of this slide, and you can see that it simply compares references. So what's going to happen, even though these two circles do have the same radius and we should judge them as being equal, we're going to get a message printed by the code on the left that simply says objects are not equal, because what we mean by that is they don't have the same reference. They are two individual objects that live in separate spots in memory, and the Java Virtual Machine recognizes that the references for each of those are different, and because of that they are not judged as equals, regardless of what the diameter or radius is, regardless of what color they are, regardless of whether they're filled or not, whether they're created on the same date. None of that matters. They simply don't have the same references, and therefore they're immediately not going to be equal. On the top right-hand side of the slide, you see the code that we would like to override the default equals method with. We would like to instead define equals to be a Boolean value that is equal to the comparison of the radii. Of course, the radiuses, or the radii, are primitives, so we're allowed to use the equals operator to compare them. And the definition, or the way that operator behaves, it actually checks to see if those numbers have the same value. So in other words, you're checking to see if the radiuses match or not. And if they do, we get true out of this expression. Otherwise, they get false. And that's the basis on which we're going to be judging circles as being equal or not equal in this context. The equals operator is used to compare primitives to see if they're equivalent or not. We can use it in the context of objects, but when we do, it's checking to see if the references are the same or not, which is probably not what our intent is. So instead we have the equals method that's intended on determining whether two objects have the same contents. But as you saw, the method that's in the object class for equals does not actually do that. In fact, it behaves the same as equals. It simply checks references. We say that the equals operator is stronger than the equals method because it actually checks to see if two objects have the same reference. In other words, are they actually the same object? And that would be the highest possible level of equality that you could reach. The equals method, however, will determine equality on some other basis. And as I said, it's up to us to determine what that basis is. And we may choose to say that circles are equal merely if they have the same color and there's no other criteria. It might not necessarily make sense, but it's certainly we're at liberty to do that if we wish. However, the equals operator is considered stronger because there's no issue about how you define equality when the object is actually, when the two objects being compared are actually one and the same object. There's no way they could not be equal under any possible measure that you might employ.